Hey guys, it's Mr. Zimmerman, and today we're going to continue our adventure going through some of the major topics in Module 3, Topic 2, and basically we're covering exponential and logarithmic functions. And in previous videos, we talked about this growth equation, and I know it's a growth equation because it's 3 to the x. If it was 1 to the x, it would just constantly be staying as 1 because 1 times 1 any amount of times is just going to give an output of 1. So that's why it's like 1.1, it's growing. If it's smaller than 1.1, so like let's say 0.9, because 0.9 is smaller than 1, you'll be able to know that it's going to be decaying just because of properties of multiplication. If you ever multiply anything by a decimal that is smaller than 1, your number, your product is going to be smaller than what you started with. So let's go ahead and take a look at the same type of question with just a different skin. So we're going to look at the function 1/3 to the x, and immediately we're like, oh goodness, what the heck? This fraction, I could handle it when it was just a number. But now that it's a fraction, what am I going to do? Well, I know that 1/3 is going to be in a decay equation. This is just from general understanding of the parent function. And as we've talked about before, when b is greater than 1, it's going to be growing. When it is less than 1, it is going to be decreasing. For those of you who like decimals, 1/3 represented as a decimal is 33333 going on forever, sometimes represented with a bar notation. So this is going to be smaller, and I need to create a value for this table. Now, some of you might be tempted to use decimals. Please just keep it in fractions because it's a lot cleaner. Watch. I'm going to start with 1/3 to the first power, which means it's going to stay the same as 1/3. Now 1/3 squared, I'm going to write it out and do some good old arithmetic, means 2 1/3s. And we have to multiply the numerator, and we're going to multiply the denominators out because that's how you multiply fractions. I'm going to get 1/9 as the output when I put 2 in. So right now I notice that when I put nice numbers into this equation, I get decimals out. Now I know it's going to have an output of 1 for 0. And now this takes a little flexibility to understand. If you understand that, hey, the difference between each of these, I'm multiplying by 3. The key to seeing this is like 1/3 to 3. How did it turn from a 1/3 into a 1? This is going to be 1 times 3 is 3, and 3 times 3 again is going to be 9. You can also do a bit of arithmetic to prove this. If I were to write it out, 1/3, and I'm going to go ahead and raise it to the -1 power. What essentially happens is the numerator becomes the denominator becomes the numerator, making it 3/1. So I got my table of values. I'm going to go ahead and plot it down. I'm going to start out with the nice ones, -2 and 9. So I'm going to go here, -2, and go up 9, -1 and 3. And the y-intercept of all exponential base functions is not at 0, 2, it's at 0, 1. And now I'm going to go ahead and try to graph this next part. This is where it's a little tricky, and having it as a fraction form or as a decimal provides no advantages. I have to understand that 1/3 is smaller than 1. 1 is right here, so I need it to be smaller than 1. 1/3 is smaller than half, so I'm going to go ahead and put the dot right there. 1/3, and what is it going to be? 1 and 1/3. So now I have to go ahead and put it at the 1 spot. In that previous example, it was not at 1. And this is going to show that it's going to constantly be decreasing. Now at 2, it was 1/9. 1/9 is a that is 0.1 repeating. So like if you want to write it out, 111, you can or estimate it to be 11 cents. So it's going to be very, very close to 0. And this is going to produce a graph. Is it decaying like we predicted? Absolutely. Now, I'm going to highlight that there is an asymptote where you see how it's approaching the x-axis. The x-axis can also be defined as y equals 0. So I know that there is a, what kind of line is it? It is a horizontal asymptote, and that is when y equals 0. Okay, well, voila, success. Now I go ahead and I have to graph this inverse of this guy. What is going to be the inverse of a decay equation? So I'm going to switch my x's and my y's. So I'm going to switch out -2, and I'm going to put 9 to the -2. Scratch out the -1. I'm going to put 3, -1. Scratch out the 0, put a 1 and a 0. Scratch out the 1, I'm going to put 1/3. And I'm doing this just to build that habit where I have to actively, with my mind, switch my x's for my y's. Now, I'm going to go ahead and start out with the nice ones again. The nice ones being 9, -2. And I'm going to go over to x is 9, -2. I'm going to go 3, -1. I have an x-intercept of 1, 0. Now I'm going to try to graph this next part. 1/3. When the x value is 1/3, it is going to be between 0 and 1. 1/3 is smaller than half. So I'm going to go ahead and try to estimate that when I am 1/3, it is going to be 1. So it's going to be right about here. And then 1/9, it's 2. So it's just going to be closer to the y-axis, but not touching. And voila. Now I'm just going to, and, looks kind of similar, actually, if you're looking at it. Now, as you predicted, there is going to be an asymptote. Now, I knew this without even looking at it, because from my last example, it was a horizontal asymptote. Immediately, it's going to be the inverse when x is equal to 0. Now, I know this without even graphing it, but it's important to be able to visually prove it as well. Now, I'm going to go ahead and talk about some of the key characteristics of this decay equation. My domain, I'm going to go ahead and look left to right. It is going to be -infinity to +infinity. My range, well, you see the asymptote prevents it from going negative, so it's going to be 0 to infinity. Now, immediately, I'm going to switch this guy. 0 to infinity. And -infinity to infinity. This is just the rules of the inverse. My x and my y's are swapped. Domain is a scan of the x left to right. The range is a scan left to right for y. Okay, now let's just prove it though. I mean, I can blindly write it, but it's important for me to actually believe. I need to see it for myself. I am a 21st century learner. So my domain, it says 0 to infinity. Is that accurate? Yeah. My line approaches 0. It does not include any negative numbers. What about my range? Does it include negative numbers? Yes. Does it include positive numbers? Yes. Boom, shakalaka. I'm glad I checked it. Now, this is all characteristics that we've already written out. You can see in my end behavior, I already have the questions pre-written. I'm going to approach it from 2 different angles. Well, let's go ahead and generate the rest of this table. My asymptotes is I'm going to have a horizontal asymptote when y equals 0. Likewise, for the inverse, that becomes the vertical asymptote when x is equal to 0. My x-intercept does not exist here, and it is going to be 0, 1. Here, 1, 0 does not exist. And now the intervals are increasing. I look at my graph. Is it increasing or decreasing as I go left to right? And it is going to be decreasing the whole time. So what is my domain? My domain is decreasing -infinity to +infinity. Let's go ahead and look at the inverse. Well, my domain is starting from 0, and it is clearly decreasing the whole time. So it's going to be decreasing, but this time my domain is going to be from 0 to infinity. The final thing to check is as x approaches -infinity, what is the general output of the function? So I'm going to go ahead and look at it as x approaches -infinity. It's clearly going to be a large number, a large positive number, so it's going to approach positive infinity. When I look at it from the right, as it's approaching, it's clearly, this is the realm of where it's going to be 0. It's approaching that asymptote. It is a bunch of decimals that are very, very close. I do this again for my inverse. I ask it, hey, as x goes to the negatives, as x goes to the negatives, as x goes to the negatives, it skyrockets. It skyrockets to the sky, up to heaven, to where all the positives are. Now, to the right, I go ahead and expand to the positive infinity towards all the positive hundreds are, and it actually is going down and down and down, and it's getting smaller. So here, this is going to be the key. It is going to actually approach a negative infinity. It's going down and down and down slowly. So, hope this helped. This is the second time we've looked at an exponential function. There are two types, growth and decay, this being just an overall cache of information on a decay function. That's it for now.